Hey guys, it's Mr. Haas here again, and today I want to talk to you a little bit about forces and the two different forces that are acting on us all the time, everywhere we go. So, we're going to start with this ramp that you guys have been using in class, or are going to use in class, and we have a ball. And I'm going to place that ball right here. So as you see, the ball is not moving, okay? And in order to get it to move, I have to apply a force. So I'm going to hit it with my finger, and it's going to roll down the ramp. That is what a force is, okay? Here's the ball again. Let's say I want it to go that way. I would apply a force. So when you apply a force, what you're applying is an energy. You're giving an object energy, and you're giving it enough energy to begin moving. So I could also say that I'm applying a force to lift it up. And if I let it go, even though I didn't apply the force and I didn't throw it down, it still fell down because there's another force that's always acting on us, and that's called gravity. Gravity is always pulling us down towards the center of the earth. So I'm sure you know that if you let something go, it falls to the ground. And that's because there's this invisible force called gravity that is always pulling every single object down towards its center, which is why you don't float away into the sky. It's why the tables and the desks and the chairs sit on the floor, because of this invisible force called gravity. Now, when we're talking in class, we also know that, man, maybe I can apply a force without touching it. So if I was to lift up my ramp, you'll see the ball move. And if the ball was moving, it must mean there was a force applied to it. Well, if I didn't touch the ball and all I did was lift up the ramp, then the force that is pulling it down the ramp must be gravity. The steeper I put the ramp, the faster the ball goes. The less steep the ramp, the slower the ball goes. These are all examples of forces. Now there are two types of forces that I want to talk to you about: push forces and pull forces. A push force is when you are applying an energy or a force to an object, and that object is usually going away from you. So if I was to roll the ball towards you, that would be a push force. Okay? If I was to roll the ball towards me, I am pulling it back towards me. Same with the ramp. I might push the ramp, which is going away from me, and if I'm pulling the ramp towards me, we would call that a pull force. So those are the two different types of forces that all forces on this planet and everywhere in the world are classified into: a push and a pull. So I want you to think right now in your head, what are some examples of push and pull forces that you know of? And then I will give you a few of my own. Okay, now that you've thought about it, let's talk about some push forces. If I am to throw a ball, I am pushing that ball away from me. Okay? Maybe some of you can do a pull-up. I know Mr. Haas does not do pull-ups very well, but if this was the bar, you could pull yourself up like you do on those monkey bars out at recess, right? So that would be a pull-up. That's why it's called a pull-up. You're pulling yourself up. Whereas if you were to do a push-up on the ground and you were to push yourself up, you're applying a push force. So I hope you now understand a little bit better about what a force is. So to remind you, a force is any time an energy is applied to an object. And a lot of times that object will start moving. If an object is moving, then a force must have been applied to it. There are two types of forces: push forces and pull forces. And you're going to use all this science knowledge that you're gaining right now when you are in class and we are working on these ramps. You're going to deal with push and pull forces, and you're going to try to make a pretty sweet ramp that will get this ball or one of these other ones to roll down perfectly and get from one point to another. All right, I can't wait to see you guys in class, and I hope you have a great day.